So, ladies and gentlemen, now it's a great opportunity for all of you to have joined again after a sumptuous lunch. And I'm sure on a Saturday, there's always a challenge post lunch. But what I believe is we need to also look into the prospects that this technology has to offer. In the morning, we had a very good session. We had the inauguration with all the leading association heads from the office bearers, and also the chief guest, Shri Dr. Girdhar Gyani sir, who is the Director General with the Association of Healthcare Providers of India. Yeah. And also the other key respondents also giving their share of insights and inputs on the subject in terms of how end users can benefit from this technology. So we have Dr. Arantara Patra, who is the National Secretary with Orthopedic and Prosthetic Association of India. Sir was also supposed to join in the morning, but due to some reasons he couldn't make it. But his presence has always been taken seriously in terms of he being actively involved with us and also being our advisory for orthotics and prosthetics. So thank you so much for your presence, sir. And I'm sure today we will also get some more insights on the technology in terms of how it can actually offer solutions in prosthetics and orthotics, and in terms of new materials coming into this space. So thank you so much, sir. Your inputs and your feedback while we also conduct these session and post the event. We will also take the keynotes and also it will be more like a backward inward kind of an approach to take these inputs to see how we can take things forward for orthotics and prosthetics as a solution and as a specialization. Sir, may I now invite Dr. Patra sir to the audience, just to introducing him. He's the National Secretary for OPAI, that's also called Orthotics and Prosthetics Association of India. Sir, your thoughts on it, and then we will start the session, sir. Thank you.
So, thank you, Dr. Shivu. So, good afternoon to all respected guests, speakers, participants, and others present in this session. It is a great opportunity that Trinity Media 3D Graphy is making its effort to popularize digital technology in the country for the manufacturing of prosthesis, orthosis, and other medical devices. My sincere thanks to Dr. Shivu and his team of Trinity Media and 3D Graphy for conducting this 2 days national conference. 3D printing is at the stage of awareness building in the country. Once it will be used by more and more professionals, then everybody will understand its usefulness, and a greater understanding will come how it has a great use in manufacturing of prosthesis and orthosis. It is cost effective and less time consuming. Actually, whenever the starters they are using, they think that it is more time consuming, but really it is not. That is the prefabricated prosthetic and orthotic products are readily available and less expensive than custom products. However, the customized products that take individual characteristics into consideration have a more better fit to patient's body, which is the most important factor in user satisfaction. The traditional and most widely adopted manufacturing method for custom orthosis and prosthesis typically involves plaster casting and is highly customized patient-centered services, and it is a cumbersome process. In contrast to the traditional subtractive manufacturing technologies, 3D printing is a technique that greatly reduces material waste, shortens the fabrication period, and eliminates the need for most skill-based manufacturing operations. Actually, the traditional technology, it involves manual registration, assessment, measurement, then develop a plaster mold, modify the plaster mold, then recheck with the patient, then vacuum lamination, thermoforming, then trial circuit, then final circuit. Like that, we have to go on doing. So it involves 2-3 days, but we never understand that days are involved and a lot of manpower is involved and a lot of wastage is there. But this 3D printing, it is digitalization, digital data by 3D scanning, digital sculpting and modification, then verification, redesigning and 3D printing. Then there is no repeated measurement. The same measurement can be used in follow-up of the patient. And what from starting from the upper extremity orthosis to the lower extremity AFOs and BK sockets or AK sockets, 3D printing takes from 4 to 5 hours to 24 hours for printing a socket or orthosis, whatever may be. Yeah, but at a stretch, whenever it is printing for a long time, we think it takes lot of time, but it reduces the all other processes, that is manual measurement, modification and other things, and that is also reduces the wastage of POP bandage, POP powder, polypropylene, water, and also most thing is it reduces the environmental pollution. So whatever this Trinity Media and 3D graphy they are doing, they are just popularizing the 3D printing in the country so that we can make use of it, and in future all of our professional can adapt it so that the cost will reduce slowly and we can make use of the technology. Thank you all.
Thank you, doctor. Thank you so much for your insights in terms of what and how this technology can help in a way going forward is very, very essentially important because orthotics and prosthetic community that we understand is probably the technology have not been exposed to an extent in terms of what was expected. But sir, now you being at the helm, I'm sure we will be able to also look at how 3D technology can be of benefit, doctor. And as you rightly said, it is not a very complicated process. It is a very simple process, making it things more convenient. But at the end of the day, we also need to see that how economies of scale in terms of making it more viable is also important in terms of cost. All of that aspects are also going to be important. So towards the end of the day, as in even while this session gets concluded, Dr. Patra sir is also going to make some recommendations while he will also be attending for some time, and then he will also be joining back. But the conscious effort is to also get a gist of what is expected from this technology for the community at large, and more importantly for the orthotics and prosthetics experts in terms of benefiting from this. So thank you so much, sir, for your valuable insights and inputs, and thank you for your presence. Now, I would like to introduce Dr. Ajay Dhoni, who is a prosthodontist. Ladies and gentlemen, he comes with his expertise and his learned, science on in the dental space. But why prosthetics and orthotics is also because he is also met with an accident in maybe 2 years back. Wow, and that actually changed the entire tilt towards orthotics and prosthetics, because also a very brave man. You will go through his presentation, you will get to know in terms of why orthotics and prosthetics he is also looking at promoting this, who is now an end user, but also to see that how he's promoting this technology through Unique as a company. So he's the customer experience manager with Unique. Unique is a company is offering aesthetic products but 3D printed to their valued partners and also to customers who are looking at these solutions. So today I have an opportunity to introduce you to Dr. Ajay Dhoni, who is going to share his share of experience and how this technology is going to be really a game changer for the orthotist and the prosthetic respondents. and also as a career, maybe as an option in terms of looking at that. But more importantly, how is it going to benefit the end user? Thank you so much, Dr. Ajay, for your time, and we will start with your presentation. Thank you so much.
Are we starting the presentation, sir?
Yeah. Yes, doctor. You are starting with the presentation. Thank you so much.
So can you see it? All good?
Yeah, all good, doctor.
Yeah.
Thank you so much. Yeah.
So firstly, thank you so much for that warm introduction. Hi to everyone. I hope today all the lectures, whatever is happening here, I think there is a lot to take away from this, and especially the technology we are talking about. It is no more any doubt that 3D printing is the future, and we are already able to now see the impact it is making in various departments. Definitely, that is there to be seen actually. And actually, sir, one correction I would like to do from your introduction. Now, it's not been 2 years actually. Now I'm no more a new amputee. I have evolved a little bit. I met with an accident actually 4.5 years before.
Oh.
And to begin with. So today I will be discussing on the topic 3D printing, how it has been a game changer for me when it comes to orthotics and prosthetics, because I myself now I'm a prosthetic user. So I firstly I was very happy to get this topic because I will be able to share some end user perspective upon like how this technology is helping me out. So thank you so much for the opportunity, sir. And myself, Dr. Ajay Dhoni, and as sir said, I have pursued my MDS in prosthodontics, but currently this is what the whole lecture is all about, how a dentist got turned into how I happened to switch my careers from somebody like a prosthodontist to customer success manager at Unique. So that's what I'm going to share with you all today. And to begin with, I would like to start from how I was as an individual, how I was as a person before my accident, a little bit on that. And firstly, I'm proud to share that I'm a son of a farmer, and before my accident, whenever I get time or whenever during the vacations when I used to get during my graduation, I used to always hit my village and farm, and I used to do farming. And I was this, and also professionally speaking, I was pursuing my master's in prosthodontics in KLE Dental College, Bangalore. And I was very much a fun-loving guy. And I was also, I should say, I was a daring kind of a person, which is why maybe I took this adversity in such a positive way. So all we can tell is even mindset definitely matters a lot about anything else. And unfortunately, on one day where I happened to meet an accident, sorry for that disturbing picture, but I hope the profession that's gathered here, I think it should not be a problem, and it should not be so disturbing actually. So when I was pursuing my first year post-graduation in prosthodontics in Bangalore, actually I happened to meet with an accident. Which happened due to which I lost my right leg above the knee. And if you look at the right side of the picture, this more or less tells the whole transformation I saw 4 years from here to here. And I'll be taking you all through like what was really a game changer for me. So it was never an easy ride. It was definitely never an easy ride. This transformation did not happen overnight. When I met with an accident, I had to totally get off from all my professional activities and everything. Basically, I just sat back at home, and I kind of worried about what my future will be, what my future is going to be as a dentist, and how am I going to walk from today. These were the questions, but the only option I had was just to keep all of that aside and just work on what needs to be done, because I always had this feeling I'm somewhere destined to go through this process or go through this kind of an adversity. So I took it in that fashion, and immediately I started my rehabilitation. And it was a process of around 75 days. First 15 days, all I did was take care of my health and do proper exercises and rehabilitation. So get to a level where I start where I'm totally fit for my prosthetic training. And this is one of my favorite videos because this is the first day when I started walking with an artificial leg. So this was that day, and that was the first steps I was taking with my prosthetic leg actually. And then God forbid, all went good for me, and maybe because of my attitude or I came up with because I always had the attitude of a postgraduate, so I did a lot of research on how an amputee can get over this, and how what is the relationship between prosthetist and an amputee, and what are the exercises I need to do. And I did address all those concerns definitely. So which made me become a brand ambassador for OSER. So that's how my journey in prosthetics and orthotics actually started. But if you look at this picture, one thing I would like to address here, no matter what I did, no matter how well I was walking, there was always one thing that was continuously bothering me, that was asymmetry of the leg and a prosthetic knee joint which you are seeing. And rather, I'm using a microprocessor leg from OSER here, Rioni. But still, I had never felt confident due to the asymmetry. And so I opted, I went with my prosthetist, and I discussed with him all the options, what I can do to get the symmetry back. And in India, the only option that was available that time was foam cover. But I always felt going for a foam cover is more of like as you all know how we are going to see that, because people somehow don't want to accept what has happened to them, and they want to hide that, or they want to get the silicone foam, because the whole idea of silicone foam cover is it replicates your skin color. And I felt that is not a right attitude, because that was focusing on hiding rather than expressing. So I asked my prosthetist, no, that is not what I'm looking for. And also with many like maintenance and water splash, these were the reasons why I never felt happy with the foam cover. But as I said, with this asymmetry, and myself as a postgraduate, I used to go and present in a lot of conferences, and whenever I wear formal pants, and I never felt confident about my how I'm looking on the stage. And for any speaker, confidence is very, very important, as we all understand, and that was very much essential for me as well. And that's when I came up with something called as unique 3D printed prosthetics based out of Spain. And this is actually my second cover, but this is the unboxing video I have. That is why I am putting this video. Otherwise, I have two covers. And the very beauty of this technology, it's 3D printed technology, and it's a customized prosthetic cover for my leg, which in turn, as you can see here, every cover is specifically designed for each person, combining the fitting to their prosthetic components in order to have the best symmetry to their leg. And this was really a game changer for me, because the way I felt about myself, no matter, like I already said you that I was walking well, and my gait was good, but still I never felt confident. So emotionally, somewhere that emotional well-being was not taken care of. It had not addressed. I always felt underconfident. So a little bit to talk on the unique cover, and this is the catalog. Actually, I have just taken a bit of this picture from the catalog, and from where I was and to reach till here, I really feel proud that to be switching the careers in this fashion actually. And this has done a world of good, and I will be sharing further how it has helped me, how this technology or how this cover has really helped me to become a complete person. Because whenever we address functional well-being, we are only addressing the 50%. The other 50% goes to psychological well-being, emotional well-being. So that is what this technology offered me. And with that, I readily started, till then I never felt confident. For example, just I'm wearing the shorts in that picture, and I never felt confident doing so before this 3D printed cover. And now I started to go out, I started to express myself, and people started noticing me. I teaching in few events like artificial limb distribution events. And the confidence basically I got was tremendous. And then this was from, I had gone to Malaysia to during my third year masters, where I happened to present a paper there, and I also won the best paper award there. And if you look at the the way it's looking, it's really hard to make out for anybody that actually the person who is standing there in the blue suits is an amputee. See, this is the symmetry that we are talking about due to this technology. It offers us to customize exactly, precisely. Even me as a dentist, when we are making impressions, only recording those precise details in the oral cavity matters a lot for the precise fit of the dental restorations whenever we talk about them, right? So the precise fit is what matters, and silicone cover, somehow I was never happy with what it was addressing. And this was in front of Petronas Towers, and all I did was expressing myself wherever I go. And I must say I'm having a lot of fun with this sort of a cover I have. And also 2 years before, in 2020 maybe, there was this Asman Foundation. Now they came up with a wonderful idea of conducting India's biggest fashion show, for where almost 35 people with different disabilities had taken part in this fashion show, where we walked the ramp, and I was the one who addressed the locomotor disability as an Aboni amputee there. And I must say it was a very good event. And again, I met a lot of people there. And whenever possible, I have always told these people that the only thing that remains to be addressed is psychological well-being. And I as a user, I totally understood how this 3D printing unique prosthetic cover is coming into picture for me, or helping me to achieve my dreams, or do what I want to do. And this is in the last 1 year, ever since I started working for Unique. My nature of the job, the nature of my job is such that it allows me to travel as well. So from last 1 year, I have been to various places where I have been stuck in rain. I have been in snow, and I think this technology, this 3D printed, basically the material what we are talking about is a thermoplastic polyurethane material, TPU material is what we say. And I must say the fit remained the same no matter what the temperature is. I have been till almost approximately minus 15 degrees. Sorry, I'm not sure why this video is not playing. Yeah. So this was, and I have been exposed to various extreme temperatures, and the fit did not alter, and I really did not have any problems with the cover or with my knee joint as such, and it only allowed me to express myself the way I wanted to be. And that's the wonderful thing about the cover we are talking about right here.
और
And
तो
and I have
कैंसिल कर अगर विजिबल नहीं है और चेंज नहीं है तो कैंसिल करना
And I have been to many trekking places. I have gone for many treks, many hikes, and everywhere I have noticed one thing. Due to this technology, what we are talking about here, it's always a great conversation starter. That is another thing what I noticed. If at all, if I mean, it's all interrelated, isn't it? Meaning, what I need to say here is, once we don't have this sort of psychological well-being, if it is not addressed, then you won't be confident to go and engage with people out there. And once you are not engaging with people, it's a harsh reality. We cannot be sitting here and thinking that, oh, nobody is talking to me. Nobody. No, I think I need to take that action. I need to get to the world, and I need to express myself. That is when I get to things. I think this is the mindset what it process, and of course this technology enhance me to, at least in my personal experience, it enhanced me to overcome all the obstacles and express myself the way I wanted to be. And again, this was in Himachal. There is this famous place called as Nagar place. Most of you who would have seen the place. And the experiences, I must say, has been wonderful. And now I'm in Goa currently. I'm walking from here, and I can walk almost like 4 to 5 kilometers. I have tried till 7, 8, 9 kilometers also sometimes. And all it takes is the acceptance. Everything comes to the acceptance first, and then everything will fall in place. Is what I believe. And I think these are my points to talk as far as the end user perspective. Wantedly, I have not covered any technical aspects of the 3D printing technology. But if any of you wants to any of you want to know anything about unique cover, you can always contact any Autobox clinic here in India. Otherwise, you can contact me. You can mail me. My Instagram page is Ajay Dhoni, as you saw there in this. And you can always contact me. You will get more information from that. And actually, I see most of our audience here today is the prosthetists and orthotists. Thank you. Firstly, I want to tell you all and thank you all so much for your service and the passion and the empathy you are putting out there for amputees, because I know what it takes for an amputee because you come across a lot of amputees with a lot of mental problems or the financial problems, and the only thing you have to do is you need to come up with a plan, you need to come up with a strategy, what is best for them. So I have utmost respect for prosthetics, the way you all are addressing the problem, but ultimately amputee is the one who need to think that effort and you need to take the extra step to go the extra mile. And so, as far as we are talking about 3D printing, as far as that is concerned, I think the quote given by Danish colleague is more probable now than never. I think maybe in 3 4 years, this is a situation we will be ending up everything downloading. As of now, we are downloading files, videos, and all these things. And maybe in 3 4 years, we will be downloading many things, many things. Already, we have started living in houses. I recently found out there is a 3D printing bridge, which is already running in Germany. The growth, of course, when will the growth be when there is an impact and everybody, I mean, the growth and the impact is there for everybody to see due to the 3D printing, and this is the way how I got profited or benefited from my amputee experience. It only made me a better person today. And thank you all for your patience.
Thank you, Ajay. Thank you. I mean, your presentation. This is the second time that I'm going through, and it's really motivating, and also really, it's you need courage to withstand that kind of a storm, and then come up and come out very strong. But I think, yeah, that's where technology can definitely do a lot of good in terms of if used it rightly to actually encourage respondents. So you are also an end user now. You are actually promoting the technology. So great. So it is wonderful to have your story, and also now that we also wish you all the very best for
Thank
the endeavor that you have to promote this, so that your experience can also be translated well to also the other end users who might be going through the same phase. So that is actually imparting that strong courage to actually build that confidence in them. Thank you so much, Dr. Ajay. Now, what I would also want is, as a technology expert, Mr. Sarup Chand, maybe any thoughts on this? And I'm sure, in fact, Mr. Sarup also was responsive and also did help to create one of these prosthetics for Unique here in India, and that was a sample try for them to have created one to give also show that experience. So because Unique happens to be based in it's a global company, but wanted to also offer that solution. So that's where an integrated model like these or a platform, we could actually engage and connect them. Surabji, your experience on this, and I mean, you also have attended Ajay's presentation the second time, and then once you have shared your inputs, and then also can take the chair as a session chair going forward. Yeah, please. Thank you so much.
So I think Ajay's story and Ajay's experience has always been very inspiring. And more than the technology, he himself is so enthusiastic and so good. It's always good to interact with him. But I think as a technology and what they have been able to achieve and do is very useful. So to whomsoever I have shown this product, they have really found it very convenient, because as of right now, most of the people had the rod, and to cover it up and make it almost identical to the legs which are on the other side, and sometimes as a fancy prosthesis, it has been very, very good. So I think as a technology and as a innovation on the dull, poor-looking prosthesis, it's a fantastic development.
Yeah, thank you, Swarupji. Now, you can start with your presentation, and then we will carry on the course, and then the other speakers to follow accordingly. So
Sure.
you can actually share your presentation.
Okay. Okay. Got there. Okay. Can you see my presentation?
Yeah, yeah,
Hello?
yeah, yeah.
Okay. Okay. So I think some of you would be aware of Adroitech, but others may not be. Just to give you a quick update, Adroitech has been working with various clients and looking at their requirement and providing them the solution, either as a equipment supply, software supply, material supply, or if the organization or a doctor is not at this moment willing to commit his investment, then provided it as a service, which has helped some of our clients to be able to expedite the process and grow much faster. Today we are about 400 plus team, which has been providing CAD/CAM solution, which has been providing the solutions related to 3D printing, have been providing solutions related to IIoT and robotic automation. Uh, we are equipped with facilities which are for production, volume production through the HP MJF and with Fuse. Fuse is an absolutely new technology which has been brought into the country, and that produces the parts in nylon PA11 and PA12, which are biocompatible. Then we have the facility of Formlab machine, which is Smart One Plus, where we have been able to work with the ceramic like zirconia, alumina, zirconia black, as well as pyrex. In addition to the thermoplastic and some of the metal parts which can be produced, we in-house have machines like Metalex and all the other machines which are being presented here. So we do lot of services job, we do lot of benchmarks, we do lot of proof of concept to be able to work in materials like high temperature resins, high temperature material like PEEK and Ultem, gels, silicone, ceramic, ABS. We provide color printing and also work on different applications from prototype, jigs, pattern making, vacuum casting, as well as functional parts, both in metal and in otherwise. So I think critical questions which come to my mind when I looked at the orthotics or started interacting with some of the doctors as to why 3D printing for orthotics. 3D printing can produce custom shapes and geometries which are not possible through the traditional fabrication technique. Devices can be made more quickly and are easier to modify and reproduce. And a permanent digital record is generated for all orthoses and any changes which might have to go through over a period of time in case any revision is to be maintained. As each patient morphology is different, the use of 3D printing is ideal for designing custom-made and effective devices since the orthosis will fit perfectly on a patient's wrist, foot, or ankle. This is why 3D printing for orthotics. It's not that the orthotics was not done before. It was very much done, but I think I did touch upon in the inaugural session that when you do it with most of the orthotic as well as prosthetic, there are standard sizes and there are variations by number in terms of sizes. But the geometry and the shapes are different for every individual, and the surgeons have to take the necessary action of correcting either the anatomy to fit the standard size or the standard shape, which lead to little more difficulty and sometimes little more pain for the patient. So 3D printing for orthotics is being used today globally for performance, adaptive custom design, guaranteed comfort, and lot more for the doctor in terms of quick modification. Similarly, in the case of prosthetics, since no two living beings are alike, one of the typical problems in prosthetic is that you are able to do the leg or the hand, which is what need to be corrected, uh, which need to be replaced or need to be added. But one need to also match with the hand or the leg which is on the other side, which is the left or the right side. And since one has to match, the two need to be digitalized together, and thereby be able to give a little more better look for the prosthetic. Traditional processes focused on functionality but never worked to match the two sides of the body. It's wrong on my part to say never. In some cases, the surgeons did work on it, but I think in many of the cases, it was overlooked. CAD and 3D printing can create designs that will meet the specific requirement. Also, it can be easily customized. Comfort is another important factor, especially combining multiple materials. So today, instead of working with one material, which could be nylon or could be ABS or any other material, one can in 3D printing combine multiple materials to be able to give that comfort to the patient. It can lead to the personalization combined with digitalization, and it is very much process driven. Uh, all of us know availability of skilled manpower, especially in B and C category towns, is becoming a very difficult issue for the doctors. And then one has to move to the center or one of the major cities to be able to get this personalization done. With the 3D printing, it being a process driven and get personalization, one is able to ensure that the same quality results are achieved, even if one has to do it in a remote place. Uh, all of us know why Indian we need to focus on the 3D printing or any other means, because as much as even in a country like US, one in 1900 are born in USA with limb reduction deficit. Over 30 million people need prosthetics today. There is a shortage of close to 40,000 trained prosthetics uh, who can work in countries like today we are now emerging country, but in the developing countries it is so. Time, cost, and accessibility is a problem and can be overcome with 3D printing, as the process is simple, automated, repeatable. Please ignore my T, and results in better comfort. Uh, the prosthetic and orthotics can address each of the part of the body or the anatomy. Uh, whether it is skull patches or it is the custom insoles. And I'll share with you some of the examples of how 3D printing has been used globally and by some of our doctors in India. It impacts the orthotic insoles, orthotic braces and dephos, cranial orthosis, prosthetic slits, prosthetic fairing, which is what Dr. Ajay mentioned just now. Of course, I have not covered the dental prosthesis because in the morning session it was very well covered, and therefore I thought that maybe I could overlook and just move to the other areas of orthotics and the prosthesis. What is the typical process? One does the scan of the stub or the part of the leg or part of the area which we need to work on. CAD of both the sides, design the prosthesis or the orthosis, do the printing, and do the post process to be able to get the best fitment. Let's look at it. Prosthesis of an amputated leg. If you look at the sheet which is right below, you would see that the scanner can scan it instead of making the tapes around the stub and then be able to create a shape. One could do the scanning of the leg or the stub itself and then could generate the prosthesis. Companies like Hulotech or companies are working on the socket extensively. as you can see, the socket could be made and the fitment mechanism could be built in as a part of the design, and therefore there is no additional work which need to be done. And since these are being done in nylon, they are body acceptable. They can be covered with the socks, or they could be covered with even the silicone. And by doing it, one is able to provide significant comfort to the patient. Any point of time you would think that there is any doubt, please put it in the question or in the chat box. I would try to address it at the end. Crispin orthotics, or for the bent legs or bent ankle or the other applications, one can do the 3D printing customized to the shape with the foot design as matching with the other foot or the other part of the limb. So one is able to do a holding mechanism, one could create a replacement mechanism, or one could create a comfort shoe itself which can be worn by the patient and can walk much more comfortably. So I would say the depots and other things could be done very quickly. The other key application is the foot insoles, and foot insoles were done by casting or by first creating the foot impression. Today there are 3D scanners where not only do you take the static load, but you could also take a dynamic load. So there are conveyor belts on which the person can walk, and that the pressure impression is taken while walking as well as while standing to be able to get the correct walking pattern of the person. And this orthotic application for foot insole can be used for uh, relieving the foot and the leg pain, for flat feet, for high arc feet, for sometime for the diabetic patients, and also in the fracture and neuromuscular disorders. So there are patients which are using them who had the cerebral palsy, abnormal walking patterns, and this could be done fairly fast on production machines, and multiple patients can be covered in a day's time. So the speed with which you can gain is also good. If you look at this one of the foot insole, this uses a lattice structure, and by using a lattice structure while retaining the geometry, one is able to provide the air cushion and the air comfort by which the foot remain cool, and at the same time the support mechanism is maintained. So another example of how the sole itself was changed to be able to meet the requirement of the patient. So companies like FitStation have now provided the scanners at different locations and do the production of the insole at one central location for dispatch to the different patients. So when I talked about the dynamic pressure, this is how the dynamic pressure would look like. And it creates a pressure trajectory, uh, divide the foot into zone segments, do the pressure zone ratios, and then create the arc height and the movement which need to be worked upon. It also looked into the mechanical property for each of the 10 zones. So if someone is having a big toe or a big leg or a big bone projection, I in my orthotic, I should be able to take care of it. Uh, it also looks into the ligament joint stress, muscle activity, and especially the rear foot movement, which is critical as I understand from the doctors. I'm not a doctor, and I'm sharing with you the technology because some of the doctors do come to us and say that can we work on this specific area. So I think the problem is you being the doctor, you work on the problems. We can only provide a technology solution, but in terms of comfort and how the treatment need to be done is something which we depend on your knowledge and your domain expertise I don't think we can claim to be domain expert in each of these areas. So it can be very, very supportive, including the tellers and other movements could be looked into. So this is what FitStation has done. They have put the brick and mortar stores, which could be the shoe shops or any of them, or could be the doctor's clinic, and then they do the 3D and dynamic scanning, which is analyzed to be able to give a shoe recommendation to the doctor, and the doctor then says, yes, I would like the softness at this part and the little more rigidity on this part, or maybe the arch need to be moved up, or maybe the supports need to be moved slightly outward to be able to support the patient a lot better. And based on that, the customization get done in the software, and from there, the printing is an easier job because it's very process driven, and therefore there's not too much of a skill which is required to do the printing and be able to fit it. So I think our job is very simple. The job of a doctor is far more difficult in terms of giving the recommendation as to how the patient will feel more comfortable. 3D printing is a tool for the doctor to convert his thought process into a physical entity which can be tried on the patient, and if not comfortable, can be modified and delivered back in a days or 2 days time. Uh, Similarly, a lot of people started working on the bionic arm. And when they started working on the bionic arm, they used the muscle and the nervous system reaction on the muscles to be able to transfer it to the finger movement or to the movement of the hand itself. When I looked at the bionic arm, there are many components and they require to be fitted very well, especially on the finger joint. They need to move up and down in terms of wear and tear. So will my plastic be able to bear that wear and tear? The data has shown and the experience has shown that with the nylon printing, it is possible to retain the shape and be able to flex the fingers repeatedly for millions of times without leading to a problem for the patient. I'm not going into the details of how the bionic arm is made. I'm just exposing and sharing how the technology has been able to build up the bionic arm and what are the type of components which are made. And there would be some metal component, but majority of it is the plastic components which are used in the bionic arm, which basically is based on source to signal processing, and there are very good electronic processes of doing the signal processing and digitalization, and then use it in the application to give the necessary reaction or the action to be expected from the bionic arm. Uh, just sharing with you few examples of how the fingers have been done, how the bending been done, achieved without they being multiple pieces. So they are single pieces and they are flexible enough for you to move. And as in the case of leg prosthetic, you could also provide some bit of fairies to make the fingers and the hand look nicer. There are hand orthotics which are being done. A company like Optimus 3D has done it extensively, which is doing the hand orthotics in different ways and also making the fairies. They restrict the movement or they also give the flexibility of the movement depending on what the doctor would like. So based on that, the hinges can be designed. Based on that, the design could be done. And if you see in the bottom case here, if I share it, you could see that I could actually create the clips so that instead of dressing, undressing, and things like that, you could also provide clips which can hold the part and can be removed at night or as per the convenience of the patient. Another splint which could be designed very easily and customized to the joint requirement and the movement requirement which the doctors would recommend for the patient. Uh, some other examples of how the splints and the holding can be done. Uh, Very interesting. Even the prosthetic ears can today be made with resins which look and can fit with the color scheme of the person so that the ear does not look awkward or does not look to be a projection or artificial. So you could work with gel, you could work with silicone, you could work with materials which are with 50A to 80A shore value and thereby provide, and then you could do the coloring or match the color of the skin. The other very interesting area which has come up lately is the back braces for the spinal injury. And that can be supported very well because in many cases the doctor would like a particular spinal joint or a set of spinal joints to be supported very well. Can it be done in terms of 3D printing? As you can see, the measurements of the back can be done, and then the exact location of how the depressions need to be done, how the holding need to be done, could be achieved. With many a time, the doctor had to resort to giving the advice to the patient to either stand up in a particular way or bend in a particular way. Now, that can be foolproof with the help of 3D printing. Companies like Adidas have now started making custom shoes which are with custom soles to be able to give comfort to the players, and especially when they get injury they can use some of these shoes which are custom built and then be able to play. The other area where there are one doctor who has come to us and has got some of the parts done is the baby helmet after the operation of this, which was done of the head. And they got the customized baby helmets. And if you see, these are locked and unlocked. I will show you in the next slide. And they can be provided with a cushion or could also be provided with air circulation. Thereby, the child could, instead of doing heavy dressing which are non-removable and non-changeable, they could also support it with the helmet, and that could be used by the patient and by the parents of the child very effectively. So these are called cranial remolding orthoses, and 3D printing is playing a big role in this direction. As you can see, nice looking. The child also does not feel the pain. And good thing is they're very light because the density of the nylon with which we are making them is about 1 and 1.05 or so. So it does not have too much of a weight, and it is required for a short period, and it is also required to fit the child head so that there is no injury to the further injury to the head where either the surgery has been done or there is a need of correction which need done. This is the example of Dr. Ajay in terms of fairies, but the legs could be, the feet can be made which could almost spring the person upward and could give the comfort to the patient. Of course, there are implants which have now started happening with the 3D printing. Since this is not the part of the topic, I didn't want to touch upon, but there could be a combination of plastic as well as metal which can be done. And many a time when doing the surgery, there is a need of fixtures which can support, especially on shoulder joints where the movement is fairly complex, and they need to be supported at the time of the surgery itself. So company like Shukla Medical uses these fixtures or supply these fixtures to the doctors based on their requirement for surgical operation. could it only be limited to the instrument, to the prosthesis, orthosis, as well as some of the things which you just saw? Could it also be extended to the customized medical tools and devices? Today, with the help of 3D printing and using the metal printers as well as the uh, plastic printer, thermoplastic, and now the ceramic printing, it is possible to achieve all of it fairly comfortably. One area which is not generally talked about, but we as a company called Adroitech is working on, is can the orthotics as well as prosthetics be supported with IIoT for signaling to the doctor directly in terms of the performance of the IoT, of the prosthetics and orthotics which have been put for the patient. And since Adroitech does have an experience in CAD, 3D printing, reverse engineering, and IIoT, we think that the data can be captured from the patient and the performance of the prosthesis and or orthotics directly, and that data can be compiled for subsequent analysis by the doctor themselves. That's all I had to say. Thank you very much. And in case you would like to contact, my contact is here. And any questions I'm willing to take, provided Dr. Shibu has the time. Thank you very much, Shibu.
So much, Murubji.
Yes.
So, as a session chair, you can lead the other speakers to also start their sessions. So now let me invite Mr. Janardhan. Janardhan, very good afternoon, and thanks for your time in the morning, sharing your insights on the subject. And now it will be very specific to orthotics and prosthetics. Janardhan, please, the stage is yours.
Thank you, Dr. Shibu. Thank you, Surabda, for a very good session on introduction of the 3D printing applications in the orthos and prosthetics. I think you have covered most of the topics which I have planned in detail. So I'll just summarize the way I have just planned it. I hope I'm audible and my screen is visible for all of you.
Yeah.
Yeah, I think worldwide the healthcare industry is something which really moving fast into the digital manufacturing, and I think Surabda has summarized the whole progress happening across the world. How 3D printing is getting adopted to various segments and applications in healthcare. Before I start the real session, I just wanted to introduce Reddington as a company who is driving this transformation across the platforms, across the industries with various solutions in IT for the consumer segment, basically for the enterprise segment, as well as on the mobility segment. So a company with almost a turnover of almost 62,000 crores last year is working with quite a number of channel partners across India and across the world, and we operate out of 40 different countries. And we carry more than today is around 250 brands of products basically in our category. So our primary business is distribution. And one of the segments which we are focusing on is basically the 3D printing business, where we are associated with companies like HP for their production 3D printing systems. Then we also have tied up with Desktop Metal for the metal solutions. And today, Desktop Metal has acquired multiple companies today to provide multiple range of solutions. Envision Tech, or now they're called as E-Tech, is one of the solutions which they bring in from their this thing on the polymer side. And we are also companies like X1 and other solutions which is coming into. So we have a complete range of solutions available with us to really cater to the healthcare segment. And I will just touch upon certain applications and how we can take it forward. As Surabda also has briefing about, everybody is unique and we need to have different designs and dimensions to satisfy everybody's requirement. So it is basically the opportunity is very big to move towards the digital manufacturing for the prosthetics and orthosis, because every body is different, everybody needs a specific dimensions they have to fit in, and they should be more comfortable when they are having these external devices connected to their body. So as briefed about, the 3D printing has a very huge opportunity in orthos and prosthetics in various activities like insoles, braces, then the cranial Surabda has touched upon. Then we have the prosthetic sockets and prosthetic. So basically, if you look at the summary of prosthetics applications comes over here, and insoles is very popular, and there are companies based out of Australia and all these companies which Suratha has already shown. Basically, the eye orthotics, they have grown big in the last 3-4 years, providing services worldwide with customized insoles for them. Then there are companies like in the clear aligners and prosthetics, really using HP 3D printers really to do that. So to sum up, the distinct applications we spoke about orthotics is basically can be for the post-surgery protective gear, or it can be for the orthopedic treatments, or it can also be for the fracture care. Then we have prosthetics for the amputees, where we can also make it as intelligent as possible by putting myoelectric devices onto that. Then we have personalized insoles, basically to really reduce the strain on your this thing and make your strain on your knees, or if you have a knee problem, or if you have any orthopedic issues, this customized insoles or personalized insoles can also be a great help for you. So they also touched upon the maxillofacial orthosis, the clear aligners, then the assistive devices. This is another big area which is coming up, where if you want to really transfer the load which is coming when you are lifting something, or if you are operating something, if you want to transfer the load which is coming on the shoulders to external equipment, this is what we call as the assistive devices. Exoskeleton is one of the devices which is getting popular in that segment. So what this technology, or if you want to popularize this kind of technologies in the industry segment, healthcare, what we need is the cost-effective solutions. And we have solutions which has come up with manufacturing as the prime objective, addressing all the concerns about throughput, cost efficiency, and the part quality which is as required for this market segment. And today, we have product solutions which is basically production ready and can give sustainability and viability for a provider who does services using this machine. Now, I think this topic was well addressed by Suruddha in the earlier session, where the personalization and customization is the key, and the design freedom and the design for digital manufacturing is another key element which can make this project more successful and more aesthetic or more comfortable for the person who wears it. Then we have the design optimization. Weight reduction is another key factor which is really helping the patients to really deploy digital manufacturing for their activities. Then the performance, cost efficiency, and eco-friendly materials. These are the things which really come up when you speak about the benefits of deploying digital manufacturing in this market segment. So orthotics, as I was speaking about, orthopedic treatment is one of the key areas where this orthotics are getting used. Then if there is a major surgery happens, and for the rehabilitation or arresting the movement of the moving part, probably one of the key area where we can work on, and we can really make it as lightweight as possible and as performance driven as possible by really adopting the design for additive manufacturing in this process. Then sports injuries and rehabilitation is a key factor. The cranial, I think Suruddha has explained quite well. Then fracture care is one of the areas where today getting into that segment, it's a huge market where you know that the road accidents and everything is really creating a lot of fractures, and patients are really need this kind of support. Then maxillofacial orthosis is another area which we can work on. So coming to the prosthetics part, today most of the companies in India are using the conventional manufacturing process, which provides them a standard design, and it might be in a mass customization which they should have adopted, and they should have different sizes, and no way it will be matching with the other leg, or you will not be aesthetically as good as a 3D printed prosthetic device. So what we are suggesting is basically you can measure your dimensions of the other leg, design for the amputee. We can design this prosthetics the way it should match with the other leg, and we can really personalize it to make it much more effective and much more aesthetic. So the manufacturing process is changing today, where we can see a lot of digital scanners getting used to really get the dimension of your body, get a design which is personalized and customized for your body, and get it printed using a 3D printer, and then get it post-processed to get the exact finish or probably the colors which you require for that. So this is what is the digital manufacturing is all about in this prosthetics market, where you will be able to use and reduce the cycle time number one. Number two is reduce the number of process which you have to do that, and more effectively, it will be more of a personalized product for you. Bionic hands, I think we also worked with a lot of startups in India, and one of the startups which has launched the first bionic hand in India is Microsoft in the Kala. So we are working with them for the last 3 years in terms of design, production, and this is one of the key areas where today Microsoft is able to provide very cost-effective solution for the Indian market with a bionic hand. It is basically, as Surabda was explained briefly on that, it works on the myoelectrically controlled acoustic, where your muscle movement is getting detected by a sensor, and that drives the movement of fingers and wrist and all these things, and you will be able to make it as functional as this thing to some extent. So various bionic hands are available, which is really very expensive today in the market, and I think Microsoft's effort in the market is able to bring down the cost for the Indian market, and they will be able to provide a really good product for the India soon on that. As I said, exoskeleton is another key area to really as a support system for the amputees or for the sake of paralysis or something of that kind. It also can really be a good equipment for you to really assist you in the job you are doing it. For example, if you are lifting a very heavy this thing, or if you are used to, if your regular day-to-day activity is by lifting a heavy equipment, or if in a defense using a heavy gun or something of that kind. So if you want to have reduce the load on your shoulders, if you want an external device to be fitted, exoskeleton is the way to go for it. And that is also made intelligent today with myoelectric sensors. And you will be able to really enhance these possibilities. So this is a big market which is coming up. Again, it is going to be a personalized solution for all of you. So Redington has done a lot of work on this. As I tell you, we are working with for the development of insoles. We are working in development of clear aligners, and also the orthosis, bionic devices. So we are working very extensively on that. And the key advantages today is the market is moving from standardization to customization, and prosthetics is yet to really change or is to reflect in India. But we hope that adopting digital manufacturing by these companies can really create a big impact using their concepts of additive manufacturing too. So what we are trying to do is basically we are bringing in technologies for you which can bring cost efficiency and sustainability in your business, where we are assuring that you will be able to print more parts per job, and these jobs will be completed in very low time or very less time, and it also can really you will be able to bring down the cost by increasing the reusability of the powder which we use it. And it also helps you to really reduce your operational cost and make these products sustainable or cost effective to match the alternate manufacturing processes right now. So the HP has brought up this technology called jet fusion technology, multi-jet fusion technology, where it is able to provide maximum parts like what I have shown in the right side of the image. We can pack as much parts we can on the job, and you will be able to get these products printed in a different time. HP uses page-wide printing rather than going to a point-to-point sintering process. So the advantage what we can offer you with the technology is that it's a powder-based technology. There is no support such as needed, so there is no wastage of material in terms of support. The products, the material, the consumables are cheaper, as well as the way it works is basically it sprays a layer of powder on the platform, and we use something called agents, which basically get sprayed in a single stroke. The agents are getting sprayed wherever the fusion happens, and that area absorbs more heat from the from the heating source provided, and that area will get fused, and the part is getting generated. So if you look at this technology, if you look at, we are sure that the job which we are given is getting completed in a fixed time, unlike other conventional technologies, point-to-point conventional technologies, where time depends on number of parts you are going to print in the job. But in this case, irrespective of number of parts, you will be able to get the print on time. So throughput is consistent, throughput is really high, and the operation cost also is much less than the other conventional technologies. So with the new throughput, with a high throughput, with more prints per day, as well as more parts per job, This is how we are trying to bring the sustainability of in digital manufacturing, and this is the way we are helping the industry to use digital manufacturing as a source of manufacturing personalized devices. So, just to illustrate an example of this, in one print job, I will be able to pack a specific size of insoles. Almost 60 pairs can get built in one job. Means that 60 patients are getting attended in one go, and that is getting printed in almost 10 hours of time. Or if you are looking at prosthetics, 10 to 16 sets can be fitted depending on the dimension of the part. And again, on the this is an example of bionic hand where we can print more assemblies onto that. So this is the throughput which we are able to achieve from these kind of printers, the new generation printers, which uses multi-jet fusion technology. And the predictability in delivery and the max throughput is what really driving this into the production environment. These examples, I think we can show it is happening worldwide, where a lot of companies are investing on bringing 3D printers for the healthcare industry, and quite a successful companies are there who is having 10, 15, 100 machines available for serving these kind of services for the healthcare industry. This just speak about the bionic hand experience what we have. I think we have made this almost 18 to 15 bionic hands can be made in a day by using this printer, and for a volume what we anticipate for the next 5 years, probably one printer can serve that this production, and that is how and that too with the investment of one machine without any tooling, as part on demand. Whenever I need a bionic hand to be made, I can just fire the print and get it. So that is the way this is going to help you. Digital manufacturing is going to help you to start venturing into a new project or launching a new product when you with a minimum investment. That is exactly what we have done with these companies, and these are the way we are able to really develop new products into the market. So if just those who wants to have a look at the technology, I just run this video which speaks about how the 3D printing happens in HP technology. So this is how the technology works, and this is so basically this is the technology which the world was looking for, basically to really move from a prototyping, 3D printing from a prototyping environment to the production. And as I said, the printing hours is basically can be is as low as 10 to 11 hours, where you will be able to get the job completed respective number of parts. And if a person who wants to really invest on a machine and start the services, this is the right machine to really get into, because he knows when he will be able to supply the part. He knows what cost he can produce the part, and more number of jobs can be done per day. More parts can be built from per job, so that makes the business much more sustainable. And we could see this one message which we have taken to the industry, and we have really done a complete study of how the system works, and we're able to explain to our partners who has already invested. And if you look at in India, we started our journey into with the automotive industry, and we started developing this market for the last 2, 3, 4 years. And today we are able to establish almost 8 to 9 partners who has already invested on this technology and working in the industry to provide services to this industry. So more and more people are coming now, and I think partners like Adroitech, they are investing a lot of money and time in really servicing this healthcare industry, and they're doing a lot of job over there, and they are also as a happy users of HP jet fusion technology. So these partners, who is basically the strength of us in terms of carrying this technology and implementing this technology for the production, and they are the one who really help us to really expand the application basis, expand the market space for us, so that we will be more and more investment happens on this technology for the production side. So it is not necessary that always this for the full job. We can also have smaller jobs put onto that and get a quick result. So if I want to have something to be urgently to be done, we can always go for a small height job and get it printed and can deliver in a very shorter time. So this is how our partners are managing the precision and really satisfying the customers with the quick deliveries which they demand for. In addition to HP products, as I told you, we are also tied up with Desktop Metal for their e-tech solutions. Earlier, this technology was called, this company was called as Envision Tech, and after the takeover by Desktop Metal, is called as e-tech, and they are the people who are developing printers in the digital light processing (DLP) technology for in the polymer. And today, they have their focus is basically on the medical segment. They have quite a number of materials which really caters to the healthcare industry. Few of them are this thing basically can be used for the internal use, or few can be used only for the external use. So if you look at printing one bridge for you, if you want to really get it printed, we can have the material which is much stronger than a ceramic and can be put directly onto your mouth. So some similar kind of materials are available with them. And if you look at the various applications which they cater to, dental is one of the key area of their focus. Then you have the hearing aids, maxillofacial applications. So there are a lot of materials available from them for various applications in the healthcare. And these machines are also available, which is for the market or for a clinic or a doctor to invest on and do the complete design and get it printed simultaneously in their own clinic. These solutions are going to help them to implement the digital manufacturing in their facility. So these are the kind of materials which we carry. We are able to really provide strong, durable, end-use material in the Envision Tech portfolio. And these are another segment where we are really focusing on, especially for the small clinics and doctors who wants to set up their own facility in their own clinics to service their patients. This is one area where we can help the industry that way. So we have the range of solutions depending on the volume of printing, depending on the size of the machine or size of the part. We will be able to choose from any of the solutions available with us, which can really fit in the budget of these clinics. So this is one of the examples with our partner support from the partners, and with and ourselves 2 machines available with us in our facility in Chennai. We have supplied almost 1.2 lakh parts for the 10,000 ventilators when the industry or market demanded during the COVID time. So all of our partners were able to use their machines 100%. They are also supported in this venture at various levels with various customers. And from our end at Reddington, We have associated with Aqua prior to this COVID time, where we were developing prototypes for them. So that confidence of using our parts in the testing and prototyping, they made them to decide that they can use these parts, which has been manufactured in HP, can be directly used for the manufacturing of ventilators. And that is how we supported them during the COVID time, and they were able to almost supply this 10,000 ventilators on time when the market demanded for that. So there is another technology which we carry is the binder jetting technology in metal 3D printing. Unlike the laser 3D printers, which go for a point-to-point sintering process, in this case, what we do is basically something similar to the HP technology. We 3D print the parts using powder bed technology or binder jetting technology, where binders are getting used to really bind the metal powder and give a geometry for that. So that part we call as the green part. And the rest of the process, which for the metallization, we always use something similar to the MIM, metal injection molding process, where these green parts are sintered using the furnaces. So if you look at a MIM process, what we need is we have to create a tool, we have to create a current cavity, and then inject the powder and get and the binder to create define the geometry. Instead of that, we use these metal powders and binding agents to really 3D print and get the geometry done for the green part. And these green parts are then sintered. That process is common for MIM as well as for binder jetting technology. So what we are trying to do is basically these are the production-ready machines available for the metal for manufacturing metal components, and this is one of the area where we will be able to help the industry. So if you look at the technologies what we carry today, whether it is an HP technology, whether it is a binder jetting technology from TM for the metal, what we are looking at is the futuristic technologies, which really is going to drive the future of 3D printing in the production line. So if you look at when the demand increases, when the throughput, as the throughput is demanding, these machines will be able to cater the throughput which is required for the industry to move towards the digital manufacturing arena. So this is what I have in my presentation. So if you have any questions, you can ask me. Otherwise, I will just pass it on to Dr. Shibu and Sarubda to take it forward.
I think Dr. Claudio has joined and Dr. Jody Tura has also joined. Thank you very much, Janardhan. May I request Dr. Claudio to give a brief introduction and then could also give us his experience and his thoughts on how 3D printing can be used in orthotics and prosthetics. Thank you very much, Doctor.
Let me introduce the concept of antimicrobial 3D printing. I'm Claudio Soto, medical doctor, physical medicine and rehab is my specialization, and Master of Innovation as well. Let me introduce Copper 3D. My company, it's a company with global presence, a startup specialized in copper-based antimicrobial 3D printing. We developed the first portfolio of antimicrobial 3D printing. We started a new sector in this industry. Our materials had international validation using ISO standards, and we won 2 NASA grants. We are a Chilean innovation ambassador through Marca Chile, a government agency that supports entrepreneurs. We were awarded as a Material Company of the Year 2 years in a row, and we were selected as a company as one of the top 5 most relevant companies in additive manufacturing worldwide. And we are a company, an FDA and EPA company registered. So our purpose is hack materials to save lives using the antimicrobial power. And our value proposal is the ability to transform a regular material into an antimicrobial material, capable of consistently and continuously eliminate a wide range of microorganisms in all kinds of 3D printed objects and solutions. So we transform this regular material into an antimicrobial material. For example, On the right, you can see from our material, a filament for FDM technology, to transforming into an antimicrobial insole to address the diabetic foot. Our material, it's capable to kill a lot of germs. We tested against Escherichia coli, Enterococco, Salmonella, Pseudomonas, Staphylococcus aureus, and so on and so forth. And we get an international validations around the world. For example, in Chile, in the US, against a very dangerous germ such as Listeria monocytogenes regarding the food contaminations in the UK, in Dubai. On the other hand, we get international validations regarding our resins against Escherichia coli, Staphylococcus aureus, Candida albicans fungus. We tested against virus, for example, against HIV-1. We tested our device using our material, and we are capable to reduce up to 58% the bioreplication of this dangerous virus. Maybe we are testing a new device, a new prototype, and trying to get finally at least 90% of reduction, logarithm 1. Another test in Institut Pasteur, we are able to reduce the human coronavirus in a very less time using our materials. Our materials are biocompatible. We tested in India, by the way, in 2 different laboratories, and our materials are completely, fully biocompatible. Sorry, apologize. We have a lot of peer-reviewed scientific literature validating in terms of scientific protocols our materials. For example, in Italy, this use-tolerant orthosis design for 3D printing using Peleactive, one of our material. Other cases of studies, 3D printing antibacterial prostheses in war veterans in the US, etc., etc. And regarding the regulatory issues, we are an FDA and EPA company with an EPA material registration. And our timeline as a company, we are a very young company. We started under the umbrella of an academic program. And now in 2022, we are trying to address with our material the India market. It's very interesting for us. Some of our materials for FDM technology, we have Peleactive based on Pelea biopolymer and with an additive based on copper. And our MD Flex, our flex material, and this is the video where our material is using to get finally an orthosis or prosthesis that you can see on the right of my screen. We came up with other solutions using our resin to produce a personalized project such as surgical guide to improve the position of prosthesis, in this case in orthopedic surgery, in shoulder orthopedic surgery. It's a very interesting case. For example, you can see the resin on the left with an intelligent design using an SLA 3D printer, and finally enter in the operating room using our surgical guide to shoulder arthroplasty. Another case, we have more than 12 surgeries using our technology, our material, and with this intelligent intelligent design, and we get finally shorter surgical time, precision in prosthesis positioning, and optimal surgical and functional outcomes. Other applications, on the left, you can see an orthosis for a girl with epidermolysis bullosa, or other cases in Brazil in maxillofacial surgeries, and some examples, for example, for orthotic prosthetic simple surgical instrument, PSIs, surgical guides, osteotomy guides, pins, etc., and personalized projects. Other examples, we think we are pushing boundaries through innovation. This is two cases: Martina, 12 years old, and Dominga, 8 years old, using a prosthesis printed with our materials, or Javier, a child with leukemia that they don't use regular toys. Now we can play with toys made from Peleactive, our antimicrobial material, because they have an immunosuppression condition. And thank you so much for this invitation. Thank you, Dr. Chibuyon. We invite you to be a part of this antimicrobial 3D printing revolution and using active materials and antimicrobial solutions to prevent infections and save lives on a global scale.